there. All right, well, you're here for 1501. Fantastic. This is Computer Science 1 for data scientists. We teach this class in Python. So great introduction to the Python programming language. It's the first class in a two-part track for Computer Science 1 and 2 for data scientists. Depending on your major, you don't take the second one. Right? All you data science folks, you'll probably be stuck with me. I tend to be the only one who teaches this since the program started back in 2016. I've been teaching it to everyone since 2016. It's been a lot of fun. We are a 4-credit class, but the way that works is we are, 2.5 hours worth of lecture and an hour 45 minutes worth of lab, and somehow that equals 4 hours. I don't understand how college math works, I'll be honest here, but labs don't count as much as lecture time, so whatever, we're here for more than 4 hours a week. So when you add it all together, if I can do that right. So today you found the room, awesome, this is nice, not too far. My office is just down the building, this way, the CIS building that has no classrooms, which is fun. Not very many buildings don't have classrooms in it, but I'll show you that later if you want. And then the lab session, Mondays, basically after class, we'll finish up lecture, grab a coffee, whatever you want to do, meet over in the lab building. It's HPEC 1190, that's the computer lab. It's not the new ELB building, it's not the fancy expensive one, but it's the older building next to it. They are attached. But we can all walk together, so hopefully you won't get lost on Monday going there. This is me, I'm Eric Chinesky. Nice to meet you. If you had a chance to Google me, I'm the only Eric Chinesky in the world. Works out relatively well, having a pretty unique name. I am a Leo Lecturer 2. I'm not a professor. The administration doesn't allow me to use that title until I've worked here for 12 years and asked nicely, and have to fill out a bunch of paperwork. There's a whole story there. This is my email address. It goes right to my phone. If you send me a message in Canvas or email from Canvas, it doesn't go to my inbox, it goes to the secondary non-priority inbox, and then it doesn't ping my phone. So if you want to email me, please actually make an email from your Gmail, right, and send it to me, and then it'll show up in my priority inbox. Because I get an email from Canvas for literally everything that happens in the class, which is nice. I keep them for archives and things like that, but that means I don't want them to go to my main inbox and to ping me every time someone turns in a quiz or does these things. So just email direct and it'll come to my phone. You can also call or text. That is my cell phone. I think I have a phone number here on campus. I've never used it because that's just silly. I have a phone in my pocket that is with me all the time. So feel free to call or text basically anytime. It's mostly on silent mode. I don't often keep it on noise because I don't need to. And I have 7 kids at home, so things are a little bit busy. If you call, leave me a voicemail. Tell me what time is good to call you back. I'm usually a late person. I got into IT, so I didn't have to be up in the mornings because mornings are the worst. I hate mornings. So I'm not usually up till 9 in the morning if I can help it, maybe even later, depending on the day. But I'm up till 2, 3 in the morning usually. So depending on when you like to work, I'll probably be around. CIS 237, it's also 239. Both rooms are attached. There's 4 doors in a row because it's this big space. That's my office location if you want to come meet me. My plan is to be there Wednesdays before class from about 11 or so until I have to walk over to this building here on Wednesdays is the plan. We can always meet virtually by appointment. So if that time doesn't work for you because you have a class, let me know. Zoom is really handy for screen sharing. That way you don't have to come here to ask me questions about your code. You can say, hey, I'm wherever I am, can we meet on Zoom? And usually in the evenings that works out pretty well. After I get my kids in bed, I'm relatively free, and that's when I get most of my work done. I won't bother reading this to you. This was the course description. I hope I copy-pasted it right out of the catalog here. It's all the things we're going to talk about. For program learning goals, so this is specific only to the data science program. If you're taking this class for a different major, these don't apply, because this is for our program, not the class. So not very interesting. But the course objectives, these are things we will do in the course. Because you haven't done Python before, most of these don't make any sense, so I won't even bother reading them. But these are different topics we'll get through, all the way from A to M. We have a bunch of different topics we get through here, but it's lots of fun. For our textbook, I'm sorry, I don't think I got this over to the bookstore. I had some issues because it's not a physical book, it's an online book, which is actually really fun. And it's somewhat cheaper than a real textbook, but you're essentially paying for a subscription, so you don't get to keep it at the end unless you print it all off as a PDF or actual paper, but no one does that anymore because that's silly. But you can save one chapter at a time as a PDF. So this is Zybook, or Zybooks. They used to be an independent company and they got bought out by one of the big publishers, and then they jacked up their prices because that's what the big textbook publishers do. I'm sorry. But it is really cool. So this is an online interactive textbook, which is really cool. So you can go to things and you can actually write Python code and run it right in your browser. which is really cool. So there are labs in this Zybook. They're called Zy Labs because everything is branded here, right? Sure, I don't need a tutorial. But you type in your code and you hit run, and then it runs, and then it will auto-grade things for you and tell you if you did it right or wrong. This is very tedious. I'm gonna be upfront here, and everyone complains about it being a lot of work. I've found the only way to get good at something is by doing it. Have you ever noticed that? Like, the more you do something, the better you get at it. So the more you program, the better you get at it. You can read a book about programming all day long. You're probably not going to get very good at it until you actually do it, though. Right? I've read a lot of books about a lot of things. I'm not very good at sports, but I can read books about sports. Doesn't make me an athlete. Right? That's just sort of how that works. So the goal of this class is you will write lots and lots and lots of code every week. Then you'll get better at it. That's sort of the goal here. So they're really cool. It takes time. It's not hard. It just takes time because it's, hey, I read about this. No, let me go do it. I read about this. Let me go do it here. And it will tell you if you're right or wrong immediately. You don't have to wait and send it to me and be like, Eric, did I get this right or wrong? It's really cool. So you get points for doing it. And we'll get to that in a minute here. So we'll do Zybooks. There are 15 chapters we get through. 16 is optional. 17 is also optional here. It's just additional stuff. They put it in here and you paid for it. So I just marked it as optional. If you want to go look at it, you can look at it. Right? But it's not content that we're covering this semester. That's also, we'll get through 15 chapters. It's essentially one a week, except for like the last couple weeks, we kind of jam a couple in here. And we'll talk about that when we get to the schedule. So you go here, you give it the code, and you can subscribe. I think it's $89 for the semester. Let's see, view instructions. No, I don't want to link. Yeah, $89 for the subscription. We can get this through the bookstore if you want to purchase this with financial aid. Just let me know. I think I just have to send them the info, and somehow you get like a code. I don't actually know what they do, but usually you do it through the websites. I don't know what the bookstore has to do with this. But let me know if that's a problem for you. I'll see what I can do. All right, so that is our textbook. That is the only textbook we have. So it actually works out well. And then it tracks as you go through it. So you'll get points for doing it. We'll talk about that in a little bit. And then for applications, I missed a link in here. Shoot, I have to go change that. We're going to use one more here. Let me go pull that up right now so I don't forget. And downloads. There we go. All right, so we're also going to download Python. Maybe I just assumed we didn't need to list that one here, but okay. Python.x. All right, and I will upload that to Canvas in a minute here. But the GitHub desktop client, let me start with this one here. We'll talk all about this. We'll have our first lab exercise will be with GitHub here. GitHub is a online hosting provider of the Git source control system. Source control is a fancy word for code. So this website is made to put code out there and collaborate with code. It's probably the most widely used tool in industry because this is a great place to put code and collaborate with code, and the website here. So there's a GitHub desktop client is one way of interacting with Git. I like it. I use it for all of my classes because no matter what language I teach, it's the same tool. Makes my life a little bit easier here. And it's pretty beginner friendly. So we'll get into this when we work on our lab next week. But we'll use this tool. It's free. You'll need to make an account. Don't pay for anything. All of our tools are free, right? You can get fancier versions of them if you sign up for like student licenses and things. Because turns out the people who sell software know that if you start using it as a student and get used to all the cool features, you might want to pay for it when you get to industry where you have a lot of money, or your company has a lot of money to pay for licenses. Your first hit's free. Essentially, they're sort of like drug dealers. They want to get you hooked on their tool because then you'll pay for it. But we're going to use all the free stuff. It makes life easy for us. All right. And then we're going to use this PyCharm tool. This is my favorite tool for developing Python code. This is our integrated development environment. All sorts of fancy buzzwords that don't really matter here. Now, notice on the page here, it looks like the only thing there is professional, right? But you can scroll down and you can get the community version for free. They just hide it on their main page because, again, they want you to get the expensive one. Just scroll down on the download. And this works on Windows, and it works on Mac, and it works on Linux if you so care to Linux main because you're one of those people who hates yourself. or thinks you're better than everybody. You're one of the two if you run on Linux first. So we use those tools. I'll show you how to install them. We'll do that next week for our first lab exercise. We'll go through installing all the tools, write our initial program. Because lab is after the Monday class, the schedule's going to be a little bit weird. We're going to talk about a bunch of stuff Monday. We'll practice it Monday, and then we'll finish talking about the stuff on Wednesday. And it should work out pretty well. So we use those tools, and then Python itself here. You'll download Python 3. Whatever that gets updated often here. They've got a bunch of different releases you can see from whenever these were here. Whatever the latest is good. Usually you want to keep up to date because they fix a bunch of things and add security fixes and add new features. We don't really use any of the new features that come out every month or every year. Right? Again, this is the intro class. We're starting really basic. So all the features that have been out there for years we're going to use. The new stuff is cool bells and whistles that once you've used the language make you a little bit more efficient. So for our purposes, we're fine. When you download Python, on Windows, it says, hey, do you want to install with administrator permissions or not? It's easier if you install with administrator permissions, but the cool thing is you don't have to. So even on the lab computers over at HPEC 1190, we can install Python if it's not installed because IT doesn't always install the things right. And I just gave up because it's a big hassle, and we can do it ourselves anyway. And it's good practice. So it'll work. It's a little bit smoother if you do it with administrative permissions, but it totally works without. So either way, it'll be fine for you here. We'll download all the tools. We'll get them up and running. Again, we'll do that in a little while here. What most people seem to care about is how you get your grade in the class. Unfortunately, we're hyper-fixated on GPA, and companies that want interns also care about GPA. It's a filter, unfortunately. It is sort of what it is here. So if you're looking to get an A, this is how you get it. So I like categories of grades. So each category has a certain weight in your overall final grade here. So doing Zybooks, like actually just reading the textbook and doing the interactive activities gets you 10% of your score. If you get all of it done, you get 10% of your score. If you get half of it done, you get 5 out of those 10%, right, of that final grade here. I could run it every week. That's a lot of work for me to do, and I just don't want to do that. So I will only check your Zybooks participation at the end of the semester. I've had people not do any of the textbook stuff until the last week of class, and then their finals week is awful because it is a lot of work, right? The goal is you're doing it every week as we cover the content. I know life happens, things get busy, you might get behind, you might even get started ahead, up to you, but getting it done gets you 10% of your final score, just for essentially reading the textbook and practicing, which is fantastic. Our labs, the Monday labs that I run, not the Zy labs. So Zy labs are part of the Zybook score. The labs we do, the exercises I give you, are going to be another 10% of your score. The goal with labs is it's essentially participation points, right? We're going to talk about a topic, we'll go to lab and practice it. I will help you get the lab done, right? No one should walk out of lab and not have it done. The goal is you get it done because this is your chance to practice it. While I'm in the computer lab, I can walk around, look over your shoulder, tell you what you did wrong, and you should get it up and running, right? It works out relatively well. So this is your chance to practice the material. Again, if you show up and you try, I'm going to help you get it done, right? Pretty easy. So like 20% of your score just from showing up and doing it. Not hard. Projects. We have projects. We'll do 4 projects throughout the semester. They make up 30% of your score. Now, these ones, I'll give you tips and pointers and get you unstuck, but I'm not going to help you write the code. These are, we do the lab, and then we have a project to practice it. And the labs are every other week, essentially. So every week we'll practice with labs, and then every other week we'll be working on applying that stuff to a bigger project where you're a little bit more on your own. I'm not going to tell you to go away if you ask questions, but I'm not going to like, hey, this is what you need to type, like I would for a lab. Okay? So that's your chance to practice. That makes up 30% of your score. For some reason, people turn in projects that aren't complete, and it boggles my mind. Like, we've got 2 weeks to work on this thing. They turn it in. They're like, oh, I couldn't get it working. And they never ask me a question about it. Makes me a little sad. But that's okay, right? If you don't get it done, that's up to you. But if it's not working, I don't know why people don't ask me questions, right? I'm sort of a nice person. I feel like I am. And I'm generally kind of helpful. Some people are scared of their profs, and I don't know why. I guess some of them are awful people and jerks. I tend to be on the other side of the spectrum of not being a jerk. Again, I probably think more highly of myself, but I'm not going to yell at you and tell you to go away. If you're asking me 50 questions every single day, I might get a little bit tired of you. And so you're like, go read the book. But I'm generally going to be pretty helpful. So that's the goal. So if you're stuck on a project, my general ask for that is you spend a good 30 minutes to an hour trying to fix your problem, trying to figure it out yourself. Being a good developer and learning how to write code well really means you know how to go find information online. You know how to go look stuff up and find stuff. There are a gazillion things you can do with code in the world. Nobody knows it all. So we go out to the internet as professional developers and software engineers and data scientists and look stuff up because we don't have it all in our head. So all the time. So you have to go find information and find out what went wrong and how to fix your problems. But you're new, so that's okay. So after a good 30 minutes to an hour, come ask me. Most of the time, within 5 minutes, I get you unstuck and get you moving again on your program. I've been doing it for almost 20 years now, right? Almost. So I started working in 2005. I'm an old person now. I feel like I'm a young person, but I'm really old now. So almost 20 years. So having some experience makes it easier to solve problems because I've seen them before, right? So give it a good half an hour to an hour of trying to figure it out yourself, and then come ask me, and I'll get you unstuck. We have one exam. We have a midterm exam. It's only worth 10% of your score. I'll give you last year's exam. I have to rewrite them every semester because, not that you folks would do it, but some people go put them online on websites like Chegg or Course Hero. Don't do that. We'll talk about that later. That really upsets me. But I'll give you last year's because I have to rewrite it. So you'll see exactly what it looks like. It's not made to be hard. It's open book, open notes, open internet, because I've never had an employer tell me, hey, Eric, do this from memory. Because that would be stupid, right? Why would you handicap your developers and say, don't look stuff up online? That's dumb. What we learn how to do is apply the things we know and solve problems. So that's what I do. And it's untimed. You've got all week to do it. So it's not... Most people do really well in these. If you do badly on it, that's a sign that things are going really bad for you in the class, and we need to sit down and talk and figure out what's going on, right? Most everyone does really well. And then our final project is worth a whopping 40% of the score. This is the largest portion of your score. You can't pass the class without the final project. That's on purpose. Everything we do throughout the semester builds up to this final project, and then we have a final result. It's not a very interesting data science-y kind of project, because we've only had 15 weeks of coding. And really, by the time we start this, you've had like 10 weeks of coding, and then you have the last 4 weeks to do your project. So it won't be anything amazing, just to set the bar a little low here, but it's a culmination of everything we've done in the class, and it's worth a lot of points. Okay, we'll get into that when we get a little bit closer. The scale should be the same. I got this off the template. If it's different, then I probably screwed something up with my copy paste. All right, our tentative course outline and schedule. So here's the plan of what we're going to do. Mondays and Wednesdays, right? So this is just Wednesday. Happy Labor Day. Hope you had a fun time off. Our intro to Python, GitHub, and PyCharm. And Chapter 1. There's not a whole lot of code in Chapter 1, but we'll start talking about Python as we go from Zybook. So you'll notice about a chapter a week. We kind of blitz through this. There's a lot of content, but we'll get through it. And then next week, variables and expressions from Chapter 2, and we start Project 0. So projects are due every 2 weeks. So Project 0 gets assigned. There's a reason we start at 0 instead of 1. If you're from math land, you start at 1 because math people are weird. Us computer scientists, we start at 0 because that's the right way to count. It's okay. And then every 2 weeks we have a project. We take a little break, so the project 2 will be due before the midterm. That way you've got time to focus on the midterm. After the midterm, we pick back up project 3. And we just keep going from there. So about a chapter a week. And then we have a midterm review that Monday and an exam. And we pick up new content. We have a Thanksgiving break, so we start the final project just before break. If you don't want to work on it over break, that's okay, right? Take a break, that's fine. There's still a couple weeks after as well, but I want to make sure we introduce the project before break so that people who like to work ahead, great, that's fantastic. Our last week of class is set aside just to work on the final project, so I can actually float around the room and help you with it here. And if anything needed to get pushed back in the schedule, we got a little bit of buffer room here in case we get behind on the schedule, but usually we do pretty well on this. And then instead of a final exam, it's final project presentations. So I'll actually shut up for once, and you'll have a turn to get up in front of the class and show your final project. You'll run your code. We might ask you a couple questions about it here. It goes pretty well. And ideally, you get it done this week, so during your final exam week, you can worry about your other final exams, because you folks have lives and other classes and are busy people, and you don't want to be worrying about this one. If you don't, that's okay. It's up to you. You get to manage your time and figure out when you work on stuff. So you've got until, I believe, the 18th, if I read the final exam schedule thing correctly, to do this. I think that's the Wednesday here, a final exam week, the way that they schedule things, because we're a Monday class that meets at 12:30. Fine, whatever, we can look it up, but I think that's right. I looked it up last night before I went to bed, and I drink a lot of coffee, by the way, I'm sorry. So just holler at me. If I'm going too fast for you, I promise it's too fast for someone else. You don't even need to raise your hand, just holler at me, because like I get focused on things and I probably won't see your hand for a minute. And then a minute later, when I've already gone too fast, it's too far away. So just shout, just holler at me. And you can call me Eric, it's okay. It makes me feel young. And I'm not professor, don't call me professor, I'm not allowed to use that title. And lecturer Eric or lecturer Treneski just sounds weird as well, so it's okay. All right, so the academic integrity policy for the course. I'm very particular about this because this one pisses me off a lot. Here, cheaters should not get degrees, and it's in all of your best interest that your fellow classmates don't cheat to get their degree. The reason is, if you cheat and get your degree, when you get hired by a company, they think you know stuff. When you can't do stuff because you cheated your whole way through school, they're going to think Dearborn did a terrible job educating you, and they won't want to hire other graduates. Right? So if your classmates cheat and get a degree, it means your degree is worth less, because they're going to think badly of us that we do a terrible job. Nobody should cheat, right? It's a lot of work, but it's not hard work, right? If you put the time, energy, and effort in, you will get it done, right? It's an intro class, I promise. We will get it done. We'll make sure that happens. So don't cheat, right? When people cheat, I have to do a lot of paperwork. There's a form I fill out that goes to the dean. I have to document all this sort of stuff here, and then you fail the class and you get reported to the dean's office and go on the naughty list. Eventually, if you cheat enough times, the dean will kick you out of school and you'll no longer be welcome here. I don't know exactly. I feel like it was a 3-strike policy at one point, but that's out of my hands, right? Once I turn it into the dean, then the dean gets to do whatever he does with it, and I've got nothing to say anymore. But if I catch you cheating, you fail my class. There are no try-agains, there are no zeros on the assignment, you're gone, right? And then you have to take it again with me, because I'm the only one who teaches this class. Just as a fun story here, because incentives are weird and we live in a capitalist society here, I teach the CIS 200 class occasionally. That's for the main computer science students. And I had 7 people cheat on the final exam. It's open book, open notes, right? But you have to cite sources, right? If you turn in someone else's work, it's plagiarism, right? You turn in someone else's work and you don't credit them, that's plagiarism. You guys all have all written English papers before, right? You know how that works? Same with code. I know there's places online that have code. I'm not an idiot. I know Stack Overflow exists. I made a lot of money copy-pasting code off Stack Overflow in the industry. The industry is not academia, though. In academia, you have to cite your source. It's not hard, I promise. Okay, and I'll show you how to do it. Okay. So whether or not you've copied off another student, you copied off a source online, or you copied off the chatbots, ChatGPT is pretty good at writing Python. I use it. It's not a bad tool, I promise. But we have to learn how to use it and use it well. You use it efficiently, because if it gives you code that doesn't work and you don't actually know how to write Python because ChatGPT has written all your code, you're screwed. And then you're going to get fired because you can't do your job. Right? The goal is we're learning how to write Python, and ChatGPT is a tool that will make us faster at writing Python. Right? So there have been lots of changes in the industry, lots of fun things here. Because I'm such an old person, when we wrote programs that you can point and click at, graphical user interface programs, right? They used to have, everything was on this terminal here. That's how old I am. I grew up on this, which was a lot of fun, but we didn't used to have things you could point and click on. And then developers, because we're lazy people, and good developers are lazy, we're efficiently lazy, you don't want to do more work than you have to. We decided, hey, we know how to write software, we can write tools that make user interfaces for us, and I can drag and drop stuff. Well, we wrote tools that made it so we could write user interfaces. You can drag and drop buttons around, put stuff on the screen, and not have to write code to do it. And it just made us faster. It didn't make developers go away. It didn't do any of this stuff. It just made us faster at our jobs here. Depending on how much time you spend online and in social media, you'll see people pitching things, be like, oh, hey, I'm using chatbots, and now I'm making millions of dollars off this cool idea. No one's actually done it without any experience. You can't be someone who's not a developer and go and launch an amazing website and make lots of money here, even with the chat tools. Right? You kind of have to know how stuff works, I promise. Okay, anyway. The academic, so it goes to the Academic Code of Conduct Committee, which the dean is on. He gets notified, and the committee here. So I failed 7 people for the final exam. I got off track here. Need more coffee. For cheating on the final exam, because they copy-pasted an answer and didn't credit their source. One person did credit their source. And I was like, okay, that's my bad. I wrote a question that had an answer online. I'll take that. You cited your source, you're fine. So that 1 of 8 passed. The 7 who had the exact same answer didn't cite their source failed. Because it was a course that was required as a prereq for the next course they registered in the next semester, which started a week later, they weren't going to be able to take that other class. So they all complained to the dean, and the dean said, okay, well, you can take it again at the same time. But because the schedule was already full and everyone was already teaching with whatever schedule here, they said, hey, Eric, can you do an independent study? I said, okay, sure. So 7 people had to take an independent study, CIS 200 with me. So I got paid to do an independent study for these students who cheated in my class. So I got paid to fail people, essentially. So the incentives are kind of fun there. Just a fun story. So don't cheat, right? It pisses me off, and I complain to my wife about it, and then she complains that I'm complaining about it. She's like, Eric, just let it go. Like, it's not hard to not cheat, I promise. It just upsets me, right? If you don't want to be here, don't be here, please. No one's making you be here, okay? Just don't waste all of our time. All right, enough of that soapbox, I'm sorry. So U of M has a ChatGPT tool for free, which is the version 4, which is one of the latest versions. Things change so fast nowadays, it's hard to keep up here. But the free one from OpenAI is still on 3.5, if I recall correctly, and now version 4 was out and all sorts of things. And U of M said, hey, let's just give everyone access to the better one, which is actually kind of cool and makes things a little bit more fair, so that if you don't have enough money to pay for the subscription fee for the better one, you just get it through school, which is great. So the chat tool is really nice. You can do lots of cool things with it here. You log in with your U of M account. It's all tracked, right? Because it's the U of M system here, so sure. But you can ask it questions like, hey, write me Python code to say hi to my CIS 1501 class. And it will spit out some code here in a second. When you install Python, you get this idle tool. I'm not a big fan of this one here, but it's super fast and easy. You can just paste Python code in and it runs. It's not an integrated development environment. It's not as nice as PyCharm, but it comes with it here. Look at that. Oh my goodness. That looks like fun. I will copy paste this one here. If I paste it in, idle is the worst. This one is awful here. Let's go over to PyCharm. It doesn't copy paste well. It wants things one line at a time. And if you give it 7 lines, it gets upset. Sure, we'll just make a new project. I'll do it this way here. Here's PyCharm. This is not the fastest tool. I do apologize, but it's a really cool tool. Got a lot of nice features, which make life easier for us when we get there. Here we go. Okay, cancel and close. All right, here, copy paste in. And hit the little play button for run, and we say, hi, CIS 1501 class. We made the computer talk to us. Yay. But again, anyway, so the tool is really nice. It does a lot of cool stuff. It can solve every project we do in this class. Let's be honest, it's an intro class. When you get into harder classes, it actually can't solve them because they're harder for it, and they get complex. And it turns out these GPT tools are really bad at math. So if anything involves math, it starts to fail because these are prose machines. What they do is they make something that looks like what they've seen before. Doesn't mean it's right. So depending on what we're asking it to do, a lot of times it will be similar to what it needs to do, and it's mostly correct here. But when you start getting into advanced mathematics, it's like, oh, hey, what's 237 times 592? Oh, it's probably going to be a 7-digit number, or whatever number of digits. Here's some digits. And it's just completely made up because it doesn't actually do math. It's like, hey, it looks like this. That's what these large language models do. They're not actually doing anything. They're learning. Here's all the things I've seen online before that I've put into my learning system. You asked for something. Usually when someone asks for something, this is an answer that looks like that. Again, it's a little bit smarter than that. There's all sorts of cool stuff you can do. But they're prose machines. They're made to generate something that looks like an answer. For our purposes, it will get the answer because we're just doing basic stuff, right? And I'm not that good at math to give it hard math, to fail it, to make it get confused. I'll be honest. Math, I can do math, but it's not my forte. I was okay at it. I had to take Calc 2 twice because the teacher wouldn't let us use a formula sheet. And I took it later in life when I was 30. And when I was 30, it was much harder to memorize formulas. And I had a bunch of kids at home and a bunch of things going on the job. It used to be easier to memorize stuff. But the second time I took it, the teacher let us use a formula sheet and I passed. So I just wish the first teacher would have done that, but whatever. All right, so there is a tool. If you use it, now notice there's no it keeps our history here, but there's no URL I can give it. So what I ask you to do is say in your code, when you go to cite your source here, there's no MLA format or APA format for this in code here. We're just gonna put a little note in here. Again, we'll talk about what all this means here in a minute, but I'm gonna put a comment in, a little note here. and my comment says, hey, here's the website I used, here's what I asked it to do. That's my way of citing my source here. Again, we'll get to it. I'll do more examples as we get there. But tell me what tool you use. There's like 8 different good ones out there for programming nowadays, depending on which one you like to use. One of my friends likes Claude a lot. Sure, whichever one you like, go for it here. It entertains him to write assignments that ChatGPT fails to do. And like that's not a hobby of his, but it amuses him to make the assignment just complex enough to make it so the chatbots fail at doing it. Yeah, sorry.
What if it's like a YouTube video or something like that? Do we also have
Yeah, just drop in the URL. Yeah. So YouTube. Let's go look up how to write Python. Hello world. Oh, I can't spell, but sure. Okay, that's not a YouTube video. That's a sponsored link. I'm bad at this. Is that a real person or is this AI generated? I'm thinking it's generated. Like it's relatively easy enough to like generate AI videos nowadays. But yeah, so anyway, same way, you just be like, hey, here's my YouTube video. Sure, and I'm happy. So again though, just like an English paper, you can't turn in a giant quotation. You're like, hey, I cited my source, here's my paper. It's a 7-page quote. You're gonna fail, right? Because you didn't do any work. So use the tools to help with pieces here, and then add your original effort, okay? The bulk of your work, right, at least half, right, probably 51% for you math folks, check me on that, right? That's more than half. Is that 51%? 50.1, if you want to get specific, should be your own work, right? Use the tools to help. They're really good at debugging things, like, hey, I'm getting an error message. Ask the tool about it. Hey, I'm getting this error when I run my code. What's going on? And it will probably tell you. They're pretty good at stuff like that. Hey, I need help with a small piece of my assignment here, not the entire thing. Great, here's a small piece. As we get into more interesting stuff, there'll be more pieces, right? The more we've learned, the more stuff we can put together. Just like a math class, all of the topics we get into build on themselves. Once we've talked about variables and expressions, we will use them the rest of the class. Once we've talked about types, we'll use them the rest of the class. Once we talk about branching, the rest of the class, right? So you don't get to skip a week. Right? We've learned it, now it's part of your toolkit. It's something you know how you can use to help you solve problems. Turns out the hard part of programming is the creative process of how to make a complex problem simple enough that you can tell a computer to do it. As much as we like to imagine computers are smart and wonderful and can do cool stuff here, they're really dumb. They only do what we tell them to do, and they will do exactly what we tell them to do. And if you tell them to do the wrong thing, it will do the wrong thing happily. Right? Because you told it to do it. It's like, okay, sure, boss, I'll do it. And if you told it the wrong thing, it doesn't work. So what's hard about programming is it's a creative process. As much of it is a science, and there's a lot of science to it, it's a creative process that says, how do I take a hard problem and break it down into small steps and spread it out into little pieces that I can solve one part at a time, right? It's really interesting. It's a really fun field. A lot of cool stuff goes into it, and that's why it works well as a team sport. Not a team sport, but you can work on a team. You can have 7 people all working on the same program, or hundreds of people all working on the same program, because they're all working on small parts of it here. We put all those small parts together, and it does a really cool big thing, which is lots of fun. All right, so you can't turn in one giant quotation, right? So even if you asked it to solve this project and then turned it in as a quote, that's not going to pass, right? Because it wasn't your work. So you have to add your original effort here, right? If you're not sure, just ask me. Until you actually turn it in to Canvas and say, Eric, here's my submission, you and I can talk about it as much as we want. And I'll tell you, yeah, that's too much, or yeah, that's fine. No, that's too much, or yeah, that's fine. Not 2 yeses, sorry. Right? Just ask me, right? And if you've used too much, I will tell you. And it's okay, because you haven't turned it in yet, right? We can review stuff, we can look at it, talk about it. But once you've turned it in and said, this is my work here, then it's official. Right? And then we have to go through the policy here, and it's out of my hands. Yeah?
Can you use it just to check your work? And would you still have to cite it? Or like, let's say you did your work on your own, but you're just not sure if it's 100% correct. Can you use it just to check it?
So checking your work is not, I don't think that's what the tools are made for, and I don't think it's going to do what you expect it to do. So most of what we're going to do with our programs is, here's a task for you to accomplish. So it takes, you give it some sort of input. The program does something, it gives you some sort of output. So for us to check if it's right, we need to say, okay, let me come up with a couple different inputs here. I'll run them through my program and see, did I get what I expected back out? So a lot like math formulas, right? We know if I give it A and I do my formula, I get B. If I don't get B, I didn't do it right. Again, one of the hard parts is coming up with what is A and B. Because if I write computer software to do something, I have to know if I give it this, this should come out. So you have to understand the problem well enough to solve it essentially in your head, right? What is happening? What kind of results do I want to get? So without getting too far ahead, like one of the first projects we do is a fence calculator. Because my neighbor has a big fence, and I looked at it one day. I was like, oh, that'd be fun. So like, can we write code to help us, our contractor friends who are notoriously bad at math, figure out how much they need to buy and how much it will cost to build a fence? So given some sort of input here, can I then generate, okay, here's how many posts I need to buy, here's how many boards I need to buy, this many feet, it costs this much money, here's how much I need to mark it up, so I'm making 10% profit, whatever happens to be. If I can do all of that on my own, then I can test my program. If I don't understand the problem well enough on how to build a fence and how to cost materials and those things, I can't make a program do that.
So it's basically you already knowing the output before you do it, but
Yeah.
just making a code for it and expecting to get the right output.
Yeah. Yeah, so for our purposes, it's easy enough for understand this goes in, this should come out. And we can test it ourselves. And that's part of the process. We'll get into that on how do we test our code to make sure it's doing what it's supposed to do. As it gets bigger and bigger and bigger and more complex, it gets harder and harder to do, right? Like imagine the folks who write Windows. How do I test that it does what it's supposed to do? It does a lot of things, right? So it gets to be hard. But again, we're going to kind of start small and focus on those small things. Yeah.
Do you care like what we use to code? Like, are we gonna need to download Python if we like have to draw with projects and stuff like that? But if I just use like visual code for
So VS Code is great for Python. It's a little slightly trickier to get running than PyCharm and doesn't have quite as many features that I found. So everything I do will be in PyCharm. If you like VS Code, go for it. You can use whatever tool you'd like to write your code. There's a lot of them out there.
Can it draw? Like VS, like are we ever gonna do, like I did shell Python before and like, you know, you can draw like squares.
Like a graphical program?
Yeah, can it do that in VS Code?
Yeah, so it's just calling the different libraries. So we'll get into that. The last, where was it here? We used to have, did they take that section out? There used to be one chapter that got into that here. I thought it was, they must have changed it here. Matplotlib will generate graphics for us and charts. This library is amazing. Like if you want to generate a graphic for something, anything, it's out there, which is super cool. We can get into. We just have to understand, here's what I feed it, here's what I put in to get this graphic out. Right? Again, you have to understand your data and what you're plotting or graphing and doing that sort of thing. Matplotlib. Let me just show you because this is super cool. Not Udemy. So here's examples here. So any of these sort of like plots here, and then, again, you can keep scrolling down and see more and more and more plots here. You can generate if you know enough code. And this is just the start here. This is just a couple of them. The tutorials page has even more, which is really cool. Like lots of fun stuff. This is one of my favorite libraries. Lots of fun to do. So we'll do graphs eventually. But that's later near the end when we do that. There's other ways to write graphical user interface programs. There's a popular library, tkinter, for that. We don't generally get into that in this class. But you can, and once you've understood the basics of Python, it's not that hard to go pick up more advanced tools and libraries. That's why we start with this one before you actually get into the data science courses that say, hey, here's a Python library, go use it. Because then you're like, I don't know how Python works, right? Turns out you can learn it, and lots of people do. I've got really smart friends in other fields here. One of my prof friends is a biologist, and he does all sorts of stuff in R, which is another statistical language here, because he had to do models of things. And so he taught himself R, essentially, which is really cool. A friend, yeah, go ahead.
I'm taking a different class right now that's using R. How similar is this to R? Because I was just thinking about that.
Relatively similar, yeah.
Not like identical, obviously, because I feel like R is like its own language, and it kind of translates just in like theory.
Yeah, you can do anything you can do in R, you can do in Python, essentially. So R was not written by developers, for developers. R was written by statisticians. and I hate using it because it was written by statisticians.
Terrible.
Super powerful, and they can use it for all sorts of cool stuff. I got a friend I went to high school with who always loved dinosaurs and said he was going to be a paleontologist as a kid. Went to elementary school all the way through high school, and now he's a paleontologist, and he teaches out of New York somewhere and works at their museum, and he gets to play with dinosaurs all day long. But he writes R code for his PhD thesis and the research he does on modeling skulls. So he builds these 3D models of skulls based off of imaging data and tracks all sorts of cool stuff here. I'm like, I don't know what you're doing. Like, he showed me his code one time. I'm like, I don't get it. I could spend like a day going through it and trying to understand it here, but like building out interesting 3D models of skulls has never been useful for me, turns out, as a developer. I've never needed to do that. So you can do all sorts of fun stuff with it. Yeah, R is a lot of fun. You'll get into that. Is it it's stat 305? One of the numbers here, I
I'm
forget.
taking a sequence right now. I'm taking a second.
Yep, which is cool, and it's really fun. Do they still use the online textbook?
Well, my professor is Thomas Fiore, and he's I took him last year, and he didn't really use the textbook.
Oh,
It was
okay.
more what's it called Data Lab, I think it was.
Oh, okay, that's a good one. Yeah, those are fun. All right, so I got off topic. It happens a lot to me. Just holler at me. I'll get back on topic. For late work, I don't take stuff late without prior written approval. Generally, I go over solutions. For the projects, the day that it's due at 12:30, and then I'll go over the solution in class. Most of the time, people say that's worthwhile, because the process I go through solving it might be different than your process, and it's going to give you an example of how I'm going to approach solving problems. So I will go over solutions to projects in class. Once I've gone over a solution, I can't take it, right, from anyone else. That's just not fair, right? So projects I can't take late. Labs I don't take late because that just means you're getting behind, and the further you get behind, the worse it is for you. Right? The goal is you're getting your labs done before you walk out the door. They're not due until the following week in case something came up. Sure, that's fine. I'm not going to penalize you because you didn't get it done before you walked out the door, but they're due the following week. I've had people get behind, and they're always a week behind on labs, and then when we're doing a new lab, they're working on last week's lab, and that's really irritating. And it's just bad for you, right? Because then you can't focus on the new stuff we've talked about. So stuff is due to help keep you on track. If something happens, because life, it's hard, I get it here. Being an adult sucks a lot, but it's also kind of fun, depending on what you get into. I can work with you, but you got to let me know ahead of time. I'll give you prior written approval, that sort of stuff. If it's some sort of emergency, I'll work with you. Please don't send me protected health information. I used to work for a healthcare company. I don't need doctor's notes. I don't need emergency room documentation here. If you tell me you're in the ER, I'll believe you. Okay, I don't want to see your private health information. That's up to you, right? I'm going to believe you. Now, if you've been in the ER 7 times in one semester, we might have a problem, or you definitely have a problem if it was real, that sort of thing. One of my friends here said he had a student in like 3 classes, essentially, because he teaches a bunch of different classes and he sees them a lot. And it turns out their grandmother died 3 times. And after the second time, he was a little confused, but the third time, he's like, 1 grandma, 2 grandma, and was a little confused here. So I'll take your excuse. Give me an excuse, I'll take it. The first time, probably the second time, maybe the third time. Eventually they run out though, right? Okay? But just let me know ahead of time. I'll work with you. We do have a food pantry, which is awesome. Contact them with my email address, Office of Student Life, whatever. This should be in everybody's syllabus. Hopefully you're bored of seeing it by now, but super cool resource here. Turns out the social science people who do a lot of interesting work here have found that if you don't have food, it's really hard to focus on learning stuff. Okay, there's this guy called Maslow, and he has this hierarchy of needs. You might have heard of that before. And you can't do the hard things until you've done the basic things, which is like, we all know this. We've all talked about this before. You might have talked about it in high school, whenever here. But colleges didn't used to care. They're like, oh, you're an adult, tough luck. And now, like, the state education and Department of Education are like, students should pass if they pay money, generally, here, so help them. And this is something we can do to help with that, which is cool. I don't know why this is still in the template, but sure, don't come if you're sick. We're not requiring masks. We did it. It was a whole long story, whatever. We lived through it. We got through it here. It sucked and changed the world a little bit here, but we'll keep going. And then university-wide policies, they're in Canvas. Thankfully, I don't have to copy-paste all of it. Goodness, we got through it. It only took an hour to get through the syllabus. Sorry to read stuff to you here. There's only a couple pages. Questions, thoughts, concerns on the syllabus before we get to other stuff? Okay, cool.
I have
Yeah.
one more question. For the textbook assignments, Are you, because you said it's due at the end of the semester,
Yeah.
that's when you're gonna check, are you gonna put in the calendar on Canvas, like, recommended do it at this week?
That's in the schedule here. I'm not going to put that into Canvas. So
Okay,
just,
I just got it.
yeah, as we talk about the topic, you should do the readings, right? If you want to read ahead, great. It's really hard for me to get people to read ahead. Given that there's points attached to it, a lot of people do it, which is cool. I can't do that with the physical textbook. So I think that's one of the cool features. You get points for doing it here. And I can show you, it gives me a report after everyone has signed up here. Use your Umish email, by the way, when you sign up. It would make everyone's life easier, just because I can probably connect it to you, unless your username or your email is like ericchinesky@gmail.com, like me, and you're only Eric Chinesky out there. It'll just make my life easier if you use your Umish one. And I'll run the report, and you can even see, so as you go through the textbook here, they all have these little like, oh, I have to go to the other view here. How do I do that? Is it the content? On your view, I don't remember how to get to it right now, but it will have like a little flag here, a little icon, and once you've done that, it gets filled in, and it's blank otherwise. So it'll help track what you've gone through before as you go, because some of these things, maybe is it in 2? Like there's like, some of them are just like click and point exercises, like this one here, yeah. So this little flag here, once you say, hey, type this as a floating point literal, but not using scientific notation with a single digit before and 4 digits after the decimal point. Oh my goodness, what a terrible question. But sure, you type something in, like 0001, right? And you hit check. It says, nope, it was wrong. It wanted 0 point. Okay, check. And now I get my little check mark here. Again, sure. But all of those will add up and will be points and that sort of thing. So I promise it's not too terrible. All right, cool. So we got a little bit of time left, so let's get into the tool. So after you've installed Python, right, you download Python, you download PyCharm. If you like other tools, go for it, but this is the one I'm going to use in class. It's usually easiest to follow along with, that's fine. There are some online ones, just like Zybooks, you can type code online. It works well enough when we start, but as we start to get to more interesting and advanced projects, it doesn't hold up as well. So I would just recommend you to start now. Yeah?
I see that like we have to pay for PyCharm.
No, please don't. No, go to the community version. This one's free.
Oh, okay.
Yeah, just scroll down. It's there, but you have to look for it.
Gotcha.
Yeah. Free for education, right? It's somewhere in here, and open source. There's a rule about it somewhere. I forget where their licensing is, but yeah, you can get a student license for free if you want. We're not going to use any of those cool features at this point. Yeah, just use the free one. So I think I noted community version. Yeah, community edition. I should put a note in to like scroll down here, because I get that question a lot. Yep, so we'll download those and then we can get up and running. So let me go back to, let me close this all out and kind of go from the start. So once we've got it installed, again, this idle tool is fine. We can just say print, hello world. The classic example, every time you learn how to program, the very first thing you do is you print hello world, make the computer talk to you. Someone started this tradition years and years and years ago, before I was born, believe it or not, because I'm not that old, but I'm old, that you make them do that. So the command for Python to make it say hello world is print hello world. This one doesn't even zoom in very well. You can go to change your options, but that's obnoxious. So idle's fine. You can open it up and do things. It's considered a REPL environment, which is another term. You can type stuff in, it remembers it, and repeat, and those sorts of things are fun, but not the tool we're going to use. Right? Some people like it. I'm not the biggest fan. So we're going to use PyCharm. Once it's installed, it is great. It will do everything for us. Now, usually it brings up your last project. I don't actually want this one here, so I'm going to go close that project. You go close project. So the very first time, it probably comes up with this, and you won't have anything else in here either because it should be blank. And we'll say, I want a new project. Okay, we'll do this next week as well because this will be a part of our lab exercise. It says, where do you want to put it here? Right, well, I have to pick a folder for it here. I think, do I even have my GitHub folder yet? I don't remember if I do or not. I'll show you how to use GitHub next week as well, but let me go grab mine for now. So all the code that I do in class, all my examples, I will put on this GitHub site. This is one of the things GitHub does as a cloud solution for Git, is it gives you a website that you can go to collaborate with. There's two types of repositories, which is just a fancy word for folder. There's public ones where everyone can see, and there's private ones where only people with access can see. The stuff I do, I'll put in the public repository because it just makes my life easy. I don't want to give people individual access, and I'm not doing anything fancy, and I don't care. It's publicly accessible, right? I've got a couple other repositories for the classes I teach if you're bored and we got to go look at other code. But you all are pretty busy, so that's fine. So all the code that I do in class, I'll put out here. I hate when people put code in Canvas. It irritates me like you wouldn't believe. because Canvas is not made for code. It's a course management tool made for course files. Code belongs in a tool meant for code, and GitHub happens to be one of those. So all of the code I do will show up here. So one of the things you do with Git specifically, and GitHub is a tool that interacts with Git here, is you can clone repositories. A clone is a copy. I have a copy of this repository. So I have a folder on my computer. That's all it is a folder. So I can say repository show in Explorer, and it'll open up Explorer. You can say show in Finder if you're on Mac land, and it puts a folder on your computer, usually with the name of the repository. So my repository is called CIS 1501 Fall 2024. That's the name of the repository. It's the name of the folder. Anything I put in this folder, Git's job is to watch. So what Git does as a source control tool is watches for files. It says, hey, I see a new file. I see you deleted the file. I see a file changed. That's all it does. It does a lot of other really cool fancy things. Our friend Linus Torvald, the founder of Linux, wrote Git when he got irritated with the other source control systems because he said, I can do better. And he did. Git is the most widely used source control tool out there nowadays. It's fantastic. Again, GitHub is a hosting or cloud service provider. They're separate here. Microsoft owns them for lots of reasons, whatever here. But they give away stuff for free. And we're going to use that free stuff because it's cool. So I have a folder on my computer now. Anything I put in here now is going to show up in the GitHub desktop client. So I've got my repository open for this folder here, and it says there's no changes. Nothing's been changed. So all Git does is watch for changes. So if I put a file in here, let me go open my folder here. I'll just do a text file for fun. I'll say, hey, I want a new text file. I'll say hello.txt. And then in here, let's put something in. Let's say, hey, hi there, happy Wednesday. And I go back to my GitHub client. I hit save, Control S for save. It's a habit of mine, but I saved the file. You got to save before it works. It says, hey, there's a changed file. This file is new. You see the little green plus here? It's a new file. Red minus has been removed. Yellow dot means it's been modified. Sure, it's just a bunch of stuff. And because it's a text-based file, it can see the contents of it. It says, hey, here's what's in the file. Turns out when we write Python code, we do that in text. So we'll be able to see all of our code files in here, which is really cool. Now, one of the things Git does to track changes is it does these things called commits. Commit is a snapshot of the folder at that point in time. So we'll have a history of commits. It keeps a history of all the changes here. You can commit as many times as you want. They're free, or essentially free. We don't pay for them. There's probably some electricity usage for doing a commit. It's negligible at some point here. But you give it a commit summary. So there's a small box and there's a big box. The small box is required. The big box is optional. So the small box here, we'll just say test file. Give it some sort of message. I don't care what you put here. Organizations have standards around what sort of things should show up here. When someone gives you a paycheck, just follow along. Do what they say. Right? I don't care what you put here. You'll see it on the website eventually. So usually you want it to be something worthwhile. Some people like to swear at their computer because it entertains them. Go for it. Whatever floats your boat. Now when I make a commit, it says there's no changes because I've made a snapshot. So my clone, my copy of the repository, now has that change saved. The cloud doesn't have it. GitHub.com doesn't have it yet because only my copy does. So Git is a distributed source control tool. So everyone working on a repository has their own copy of it. Once you change your copy, no one else knows about it. So the terms that we use for Git is push and pull. So you push changes out to the central location, generally as a cloud service provider. You can pay a lot of money and host Git stuff internally on a private network if you're paranoid or work for the government and don't want to put it out in the cloud. Sure, go for it. It's your own money. Spend it how you want here. I use the GitHub Cloud because it's easy and it's free. So I'm going to push my change. And now it says, hey, I can push up here. I can push over here. I can go, if there's another button for push, I can hit Control P. Anything you can do in programming land, there's like 3 ways to do or more because people like their options. Some people think they're fancy and never take their hands off the keyboard. Sure, that makes you feel good about yourself, go for it. I like my mouse. I'm fond of using a mouse here. So I'll just click a button. I'll say push origin. Origin is the central repository, the cloud in our purpose here. But again, it doesn't have to be out in the cloud. So now my repository, my copy, and the cloud are in sync. So unlike a OneDrive or Google Docs or anything like that that automatically sync for you, it's a manual sync. So I'm going to make the change and I'm going to sync the change. So commit to grab the snapshot and then push to sync. If more than one person is working on the repository, if something changes, then you'll have an option to pull. So if there's a change out there that you don't have on your copy, you'll have to pull that change down. For us working individually, everything is a push. So for my computer, I push, my computer, I push, my computer, I push, because you're the only one working on it. When you're working collaboratively, you'll push and pull, and there's a whole process for it. It gets really fun. Eventually, we might work with partners on the final project. It's not required for this class, so I usually give that as an option. I'll show you how some of that stuff works. But the next step is you can go to the website. So you can say repository, show view on GitHub, or click the view on GitHub button here, and it'll launch out the website. Now you can see there's a file, hello.txt. All of the file names are clickable links. So I can click on it, and it will give me a text view of that file here, and I can actually see everything here, which is really cool. So hi there, happy Wednesday. I can see all of that. So what that means now is if I make a PyCharm project in this GitHub repository folder, when I tell it where I want to make this project, don't take the default. We're going to put it in our GitHub folder. Again, I'll show you how all that works later. So let me go find mine here. I've got too many of these, I'm sorry. And I never bother cleaning it up because I'm lazy. Now, I don't want it right in the folder here. I want to keep things nicely organized. So here's the main repository folder. I'm going to make another folder. So after this, I'll say, hey, here's Hello World. So it'll put it inside of a folder called Hello World inside of that folder. Right? It makes my life easier. I found people don't know how files and folders work lately anymore because you just go to like Finder and hit find a file. And on your phone, we don't really think of folders on phones anymore. So we've gotten a little spoiled. Working with folders is important. So we'll practice it, don't worry. And I'll say, great, this is all fine. New environments, this is a good practice. It makes it a little bit slower here. We'll talk more about that, what it means later. I like the option, great. And then we got this nice little checkbox for create a main py welcome script. I love this checkbox because it starts you off with a file. If you don't check this, you have to go make your own Python file. Again, I'm lazy. I don't want to do more things than I have to, so I'm just going to check the box and let the tool do it for me. We got 5 more minutes, right? Okay, cool. So, because Git is the most widely used source control tool in the world, all of the tools we use to write code know how Git works. So it's telling me, hey, do you want to add this to Git? Don't bother here. So PyCharm itself can work with Git for us. I found the GitHub desktop client is easier. And again, I use the exact same one for every class. It makes my life easier to show one. But you can do Git stuff from PyCharm, so it always asks you about it because it wants to be helpful. Sometimes it's obnoxious, and I just ignore it here. Again, I'm just going to go delete all the intro stuff here. So in PyCharm, we get 2 main windows. We get our code view. This is the bigger tab here. And on the left-hand side, we have the project view. This is just, here's the folder, and here's all the stuff inside of it. So here's the Hello World folder. It's a little small to see here, but if you hover over, it says, hey, it's C, users, Eric C, documents, GitHub, CIS 1501-fall 2024/Hello World. That's the folder. This is the path. This is where this folder is. If you're ever not sure, you can right-click on it and say, I want to open in Explorer, and it will open up File Explorer right to that folder. Right? Life is good. We can always go find these things. Right? And then it says, hey, here's this venv, that's the virtual environment. It's essentially a copy of Python because you can do all sorts of things. And if you do the wrong thing, you're going to screw up your Python install. Nothing we do will be the wrong thing, but later on, when you use all sorts of interesting advanced libraries and experimental stuff, you could screw up your main Python install, and that makes everyone sad. So that's why virtual environments are nice. You essentially get a copy of Python that you can screw with. And if it breaks, no one cares. Right? You didn't break anything on your computer. And then we see the file main.py. And again, out here, I'm zooming in here. So control mouse wheel usually does zoom, which is nice. Again, another reason I like this tool here. So I can say, hey, I want to print hello world. This is the classic one here. And then again, I got the run button here. I can right click and say run. I can go to they got rid of their menu, which upset me. Because I hate change because I'm an old person. But you click the hamburger menu and then you get your menu back. I don't know why that's helpful, but sure. And you can say run. Again, right click run, click the play button, go to the run menu. However you want to do it here, go run. And then you get another window. Now I have 3 different sections of the window. I get this terminal view down here, and it actually showed me the output of my code. Behind the scenes, if you like to do stuff the hard way here, you can run the code that it's running here. So because Python is what we call an interpreted language, the Python executable here, this is a Python program that runs. Depending on your operating system, it's different. Right? So the fine folks at Python wrote a Python exe for Windows, they wrote a Python exe for Linux, they wrote a Python exe for Mac, they wrote Python for a calculator. There's a calculator that runs Python. It's the coolest thing. It's better than TI, and it's cheaper. Because Texas Instruments has a monopoly over the math, and they're just awful people, and they've never dropped the price of their calculators. Like, I was in school, it was $200, and it's still $200 for a TI-84 or whatever now, right? Like, that makes no sense, right? Because they have a monopoly. Anyway, that's Python, and it says, hey, here's the Python file. Notice it ends with py. That's just a shortcut to tell you it's a Python file. It doesn't have to end with py, but if it ends with py, it just your operating system is happy, and it's like, oh, hey, that's a Python file. So this Python executable runs this Python file. It says, hey, Python, go read this file and do what it says. And what my file said is to print hello world. Very fun. So I can go to my terminal here, and I can paste in this command if I want. Again, not very exciting, but you can if you want to. Here, copy and paste, and I get the output hello world. I did it from the terminal because I'm so fancy now. You're all impressed, right? Look how cool I am. This is the hard way. Later on in life, it turns out the terminal is actually very useful. You can do lots of cool things with it. We can automate lots of tasks with the terminal. So it's very useful for that sort of thing. So if we write a Python program that should just run to go crunch some logs or do whatever we want here, cybersecurity folks love crunching logs, and they like to see who accessed what and those sorts of things. Terminal commands are really good for that. Sure. But now that I save my project, I come back to the GitHub desktop client and it says, hey, there's a bunch of stuff here. Holy cow. Anything that's in this .idea folder means it's a PyCharm file. So .idea, it has a bunch of stuff in here that tells it all the interesting things about PyCharm, and that will open up as a PyCharm project. Just let it be. Just leave it. It's okay. There's nothing to worry about. The important one is the Python file, but we're going to commit all of it here. So here's my little snapshot for Hello World project. Again, the commit summary, the small box is required. I say commit my computer as a snapshot, and then I push to get it synced with the cloud. Now I can go view it on GitHub, and I can see now there's a Hello World folder. If you click the folder, it opens up the folder, right? Just like File Explorer kind of does for us. I can go to my main py file, and I can see here's the Python code. So what's cool about GitHub is you get your code out in the cloud, and then later on in the semester when you're having trouble with your code, you're like, hey, Eric, I'm having trouble with this here. You can just give me the URL here and say, hey, here's my code. You don't have to email me attachments because, again, code, we shouldn't do that. We've got tools for it here, and we'll get into all that more. We'll practice more on Monday. Our first lab will be practicing all these things, getting your own Hello World up and running, and we should have a lot of fun. So I'll see you folks Monday for lecture, and then immediately after we'll go to lab. All right, take care, everybody.